Have you ever wondered why the night sky sometimes dances with color? The spectacle of hues darting across the sky, known as the Northern Lights or Aurora Borealis, has been the subject of fascination and intrigue for countless generations. This celestial phenomenon, with its ethereal display of greens, pinks and purples, has been woven into the fabric of various cultures, each interpreting its significance through a unique lens. For instance, the Sami people of Scandinavia regarded the auroras as a harbinger of good fortune, while some Inuit tribes of Alaska believed them to be the spirits of the animals they hunted. On the other side of the globe, the Maori of New Zealand, who witnessed the Southern Lights or Aurora Australis, interpret them as fires lit by their ancestors. In Scandinavian folklore, the aurora was often seen as the Bifrost Bridge, a radiant, burning rainbow bridge that reached between Earth and Asgard, the realm of the gods according to Norse mythology. The Cree of North America, meanwhile, believed the lights to be the spirits of their departed loved ones trying to communicate with those they left behind. These interpretations, while rich in cultural significance and historical context, are the attempts of our ancestors to make sense of the incomprehensible. They are the tales spun by generations who looked up at the night sky, mesmerized by its vibrant, pulsating colors and the mysteries they held. But as we've advanced in our understanding of the world around us, we've come to realize that the source of this luminary spectacle is not mystical or supernatural, but rather a result of complex scientific phenomena. The truth behind these celestial lights lies not in folklore, but in the fascinating world of science. In the coming scenes, we'll delve into the heart of this mystery, exploring how the interplay between solar winds and Earth's magnetic field creates this stunning spectacle, painting the sky with an array of colors that has captivated mankind for centuries. So join us as we embark on this journey of discovery, unraveling the secrets of the Northern Lights. It all starts from our very own star, the Sun. This celestial body, although millions of miles away, has a direct influence on the spectacle that is the Northern Lights. But how exactly does this happen? Well, let's dive into the concept of solar winds. Solar winds, contrary to what the name might suggest, are not gusts of air like the winds we experience here on Earth. Rather, they are a continuous flow of charged particles that the sun emits into space. These particles are primarily electrons and protons, and they're ejected from the sun's outer atmosphere at incredible speeds, sometimes reaching up to 1,000,000 miles per hour. Now you might be wondering, why does the sun emit these particles? Well, the sun is essentially a giant nuclear reactor, where hydrogen atoms continually fuse to form helium. This process releases a tremendous amount of energy, some of which is discharged as these charged particles. These particles, once released, don't just float aimlessly in space. They're carried across the solar system by the sun's magnetic field, which extends far beyond the outermost planets. This flow of charged particles is what we refer to as the solar wind, but here's where things get interesting. These solar winds are not uniform. They can vary in intensity, depending on the activities happening on the sun's surface. For instance, when the sun experiences what we call solar flares or coronal mass ejections, intense bursts of radiation and particles, the solar wind can become especially strong. These stronger gusts of solar wind can have far-reaching effects, particularly when they reach our home planet Earth. And it's here, in the interaction between the solar wind and Earth's magnetic field, that the stage is set for the grand spectacle of the Northern Lights. These solar winds then embark on a journey that leads to the creation of the Northern Lights. This journey, as you will see, is a cosmic dance of particles and magnetic fields, a symphony of science that results in one of the most breathtaking displays in the natural world. As these solar winds reach Earth, they meet a formidable defender, our planet's magnetic field. This is not any ordinary shield, but a naturally occurring protective barrier that plays a crucial role in our survival. Let's take a moment to understand what this magnetic field is all about. Imagine the Earth as a giant bar magnet with two poles, the north and the south. This giant magnet creates an invisible yet powerful force field that extends from the interior of our planet out into space. This is the Earth's magnetic field, and it's constantly at work, although we can't see or feel it. Now, why is this magnetic field so important? Well, it serves as our planet's first line of defense against the onslaught of solar winds. These solar winds, as we learned earlier, are streams of charged particles that the sun hurls out into space at incredible speeds. Without our magnetic field, these particles would directly strike the Earth's surface, potentially causing significant damage to our planet's atmosphere and life as we know it. But here's where the Earth's magnetic field steps in. As these solar winds approach Earth, they encounter the magnetic field, which acts like a deflector shield. The magnetic field guides these charged particles towards the Earth's poles, keeping the majority of them from reaching the surface. This process is not just about protection, it's also about beauty. As the Earth's magnetic field deflects these charged particles, they start to interact with the gases in our atmosphere. This interaction gives rise to a spectacular light show that we know as the Northern Lights or the Aurora Borealis. The Earth's magnetic field is a fascinating aspect of our planet. It's an invisible shield that not only protects us from potentially harmful solar winds, but also contributes to one of the most awe-inspiring phenomena we can witness. When these charged particles hit our magnetic field, that's when the magic happens. It's a cosmic dance, a testament to the intricate and beautiful interplay between the sun, the Earth, and our protective magnetic field. The interaction between the solar wind and Earth's magnetic field sets the stage for a spectacular display. As we journey further into this cosmic ballet, we find ourselves in the midst of an intricate dance of particles. A dance that paints the sky with its mesmerizing steps. This dance begins with the solar wind, a stream of charged particles ejected from the sun. These particles, fueled by the sun's energy, race across the solar system, brimming with potential energy. Now enter Earth's magnetic field, our planet's silent protector. A force field that shields us from the sun's relentless onslaught. As these charged particles from the sun approach Earth, they don't just slam into our atmosphere. Instead, they are guided by the Earth's magnetic field, much like a cosmic traffic controller, directing them towards the north and south poles. As these particles hurtle down towards the poles, they embark on a collision course with the gases in our atmosphere. Oxygen, nitrogen, the very gases that sustain life on our planet, now become the canvas for this cosmic artistry. But what happens when these high-energy particles collide with the gases in our atmosphere? The energy from these particles is released in the form of light. Each collision, each release of energy, illuminates our night sky, one particle at a time. Different gases give off different colors when they are excited by the charged particles. Oxygen, for instance, gives off a greenish-yellow light, the most common color we associate with the Northern Lights. Nitrogen, on the other hand, gives off blue or purplish-red light, creating a captivating spectacle that leaves onlookers in awe. So, when you look up at the sky and marvel at the shifting, swirling colors of the Northern Lights, you're witnessing the dance of the particles. It's a dance that takes place millions of miles away, in the cold vacuum of space, yet it has the power to light up our night sky with its breathtaking beauty. This beautiful display of lights is what we know as the Northern Lights. Ever wondered why the Northern Lights display a variety of colors? This magical display is not just a beautiful spectacle, but also a science lesson in disguise. The different colors that we see are the result of particles from the sun colliding with different types of gases in Earth's atmosphere. You see, the Earth's atmosphere is composed of various gases, each of which corresponds to a specific color when hit by these particles. The two main players in this cosmic light show are oxygen and nitrogen, gases that are abundant in our atmosphere. When charged particles collide with oxygen, they get excited. This excitement causes them to emit light, and depending on the level of energy and altitude, this light can be green or red. Green is the most common color of the aurora and occurs at lower altitudes, while red, a rarer sight, occurs at higher altitudes. Now let's talk about nitrogen. When solar particles hit nitrogen molecules, they produce blue or purple lights. The blue color is typically seen at even lower altitudes than the green, while the purple lights often appear at the outer edges of the aurora, blending with the red to create a beautiful violet fringe. Sometimes, under certain conditions, these colors can mix, creating hues of pink or a golden yellow. This happens when there are different types of gases present at the same altitude, or when the incoming solar particles are especially energetic. So the next time you look at the Northern Lights, remember, you're not just witnessing a beautiful display of lights. You're seeing a dance of particles and gases, a cosmic ballet painted across the canvas of our sky. Each color tells a story of a collision, an interaction, a dance between the sun's energy and our planet's atmosphere. The variety of colors in the Northern Lights is truly a testament to nature's artistry. Now that we know how the Northern Lights are formed, where and when can we best witness this spectacle? Well, let's dive right in. To spot the Northern Lights, also known as Aurora Borealis, you'll need to be in the right location at the right time. These lights are most commonly visible in high-latitude regions such as the Arctic and Antarctic. If you're in the northern hemisphere, countries like Canada, Iceland, Norway, Sweden, and Finland are prime viewing spots. In the southern hemisphere, the lights are known as aurora australis and can be seen from high southern latitudes in Antarctica, South America, New Zealand, and Australia. Now, on to timing. The northern lights are active all year round. However, because they are only visible when it's dark, your best bet is to try during the winter months when the nights are longest. The time from late September to late March is usually the best. The lights are most active between 10 p.m. and 2 a.m., but don't be disheartened if you don't see them right away. Patience is key when it comes to aurora hunting, but it's not just about location and time. The clarity of the sky plays a crucial role too. Clear, dark skies with no light pollution offer the best conditions, so rural areas far from city lights are ideal. Weather also factors in, as cloudy skies can obscure your view. A little planning and checking the weather forecast can go a long way. And finally, the further you are from the magnetic poles, the rarer the northern lights become. So, latitude matters. The closer you are to the poles, the better your chances of catching the elusive aurora. Remember though, while these tips can increase your chances of witnessing the northern lights, there's no guarantee. The aurora is a natural phenomenon and can be unpredictable. But don't let the unpredictability deter you. The hunt is part of the adventure. With the right conditions, witnessing the northern lights can be an unforgettable experience. The northern lights are more than just a beautiful spectacle. They are a testament to the dynamic and ever-evolving nature of our planet and its interactions with the cosmos. Let's take a quick recap. We started our journey by unraveling the source of the northern lights, the sun. It's the sun's eruptions that send out solar winds, streams of charged particles, into the cosmos. These particles travel millions of miles across the vacuum of space, only to be drawn in by the Earth's magnetic field, our planet's protective shield. But the Earth's magnetic field is not just a shield, it's a guide that directs these particles towards the poles. And here, in the cold, dark expanse of the Arctic and Antarctic, the dance of the particles begins. When these charged particles collide with the atoms and molecules in our atmosphere, they transfer their energy, causing the atmospheric particles to become excited. And when these excited particles return to their normal state, they release their energy in the form of light, painting the night sky with vibrant hues of green, red, yellow, and even purple. The colors we see in the northern lights are not random. They are a direct result of the type of gas particles the solar wind particles collide with. Oxygen atoms, for instance, give off a green or red light, while nitrogen molecules produce blue or purple hues. It's a beautiful natural light show, orchestrated by the laws of physics. And the best part? This spectacle is not restricted to a particular time or place. Although the northern lights are most commonly associated with the polar regions during winter, with a little bit of luck and clear weather, they can be witnessed in various parts of the world, and at different times of the year. So the next time you gaze at the night sky, remember the incredible journey of the particles that paint it with color. The northern lights truly are a marvel of the natural world.